Okay, I would like us to continue on the exercises of pseudocode. Don't mind the background noise. So, exercises one, write a pseudocode to check if a number is positive, negative, or zero. Two, write a pseudocode to calculate the sum of the first 10 natural numbers. Three, develop a pseudocode for a simple login system that checks a username and password. Example one, write a pseudocode that reads two numbers and multiplies them together and prints out their product. Example two, write a pseudocode that tells a user that the number they entered is not a 5 or a 6. Example three, write a pseudocode that performs the following. Ask a user to enter a number. If the number is between 0 and 10, write the word blue. If the number is between 10 and 20, write the word red. If the number is between 20 and 30, write the word green. If it is any other number, write that it is not a correct color option. Example 4, write a pseudocode to print all multiples of 5 between 1 and 100, include both 1 and 100 in terms of consideration. Example 5, write a pseudocode that will count all the even numbers up to a user-defined stopping point. Example 6, write a pseudocode that will perform the following. Read in five separate numbers, calculate the average of the 5 numbers, find the smallest, that's the minimum, and the largest of the 5 entered numbers. D, write out the results found out from steps B and C with a message describing what they are. Then I have more. Homework 1, write pseudocode that reads in 3 numbers and writes them all in a sorted order. So meaning that now you can arrange them in terms of increasing order, decreasing order. Homework 2, write pseudocode that will calculate a running sum. A user will enter numbers that will be added to the sum, and when a negative number is encountered, stop adding the numbers and write out the final results. Of course, that is more involving now. I would like us to look at decision trees. I know the title says decision trees and decision tables, but I'll only stop at decision trees. So, decision trees definition. A decision tree is a graphical representation of possible solutions to a decision based on condition. It consists of nodes or decisions and branches, the possible outcomes. So the nodes, the roots, they are the decision. Then the branches represent possible outcomes. So example, create a decision tree for deciding whether to go outside based on the weather. So start. So you start. So start. Then is it raining? This one is now the this is the node, the root. Then you branch. Is it raining? So this is what we are considering. Then more branches. Okay, so the branches or the leaves. Then the leaves are the output. So it can be either yes or no. Then if it is yes, take an umbrella. If no, enjoy the day. Now, a decision tree is very important, especially in artificial intelligence. It is used in machine learning algorithms, especially the ones that perform classification, any form of classifying data, will have to implement an aspect of decision tree. So decision trees are still important. Now, question 2, is it too cold outside? Now, if yes, wear a coat and go outside. If no, go outside in comfortable clothes. So you can develop the decision tree. The time now we also you can develop this decision tree. Now we also have another example here of decision tree. Time of day. So is now this one is the node, the root. So then we branch. So we have the branches. Then the leaves. The leaves are now whatever that we are considering. So we have here the node, the root. So this is node 1. Is it morning? What time of the day is it? Now, in this case, we're only considering to morning or afternoon. Now, if morning again, morning now becomes another node. This one also becomes another node. Then from there, we branch. So branches, so morning. If morning, are you tired? So if you are tired, is either yes or no. Now here, is it morning? Either is no or is morning. So in this case, are you tired? Yes or no. If you're tired, then drink coffee. If you're not tired, then there's no need to take coffee. Now, is it in the afternoon? Now, is it in the afternoon? Then are you tired? So is either yes or no. So is it in the afternoon? If yes, then are you tired or no? So no. Then here, are you tired? Yes. No. If you're tired, drink coffee or no. Then we can have a more realistic way of implementing a decision tree. For example, in automatic loan evaluation, a loan application and a loan approval, you implement an aspect of a decision tree. Now, we have here the what we are considering or the task is loan approval in banking. So the input features or what to consider: income, credit score, employment status, and loan history. Okay, so these input features, they form what we call the roots, the nodes. So the what are you going to consider? So we have here node one. We can have the credit score. Is the credit score above 650? It can be yes or no. If yes, continue evaluation. If no, reject the loan application at this stage. Now, if it is yes, we go to node two. Now, node two, we are now evaluating the income. Is the income above $50,000 per year? Now, in Kenya, you can consider maybe in Kenyan shillings. Now, if yes, you continue evaluating the loan application. If no, you reject the loan at this stage. Now, we go to node three, employment status. So is the applicant employed full-time? If yes, continue evaluating the loan application. If no, reject the loan application at this stage. Now, node four, loan history. Does the applicant have a clean loan history? No defaults. If yes, approve the loan. No, reject the loan. Now, in this case, if it is yes, you automatically approve the loan. If no, you reject it. Now we go to decision outcomes. If all conditions are met, e.g., the credit score, income, employment, and loan history, the loan is approved. Otherwise, the loan is rejected. So, this is like a more stricter way of evaluating and approving loan, because an applicant has to meet all of the consideration, which are how many? Three, all of the four considerations. But in the real world, um, what usually happens is that if the applicant meets a sum of the conditions, then some of the loan amount can be approved. So in this case, if the applicant was applying for 1 million loan, if the applicant meets some of the condition, maybe the applicant may get only 150,000 as the approved amount. But if the applicant meets all the four conditions, then in that case, the applicant will get all the 1 million. So you can have here the decision tree in diagrammatic form. Credit score, is it greater than above 650? It can be yes or no. So the branches, then then it will lead us to another node. So is the income greater than $50,000? Now, in this case, if the credit score is not above 650, reject the loan application at this stage. If yes, continue evaluating. Is the income greater than 50? If yes, continue evaluating. If no, reject the loan application at this stage. If yes, evaluate on the condition: is the applicant employed full-time? If yes, continue evaluating. If no, reject the loan application at this point in time. Now, does the applicant have clean loan history? That means no defaults, no delays. So in this case, if yes, approve the loan. If no, reject the loan. So this is a more aggressive way of approving the loan. Okay, because you have to meet all the condition. But in the real world, if you meet some of the condition, then you will qualify to a lesser amount, not just total rejection. Now we go to predicting exam results in education. So this is also another decision tree. So the input or the nodes, we have attendance, time spent studying, previous grades. Node one, attendance. Is the attendance above 75%? Yes. Continue to the next question. No. Then is considered fail. Node two, study time. Does the student spend more than 2 hours a day studying? If yes, continue evaluating. If no, then the applicant is considered failed. Then node three, previous grades. Did the student score above 60% in the previous exam? If yes, assign pass. If no, assign fail. So we also have another consideration of decision table, but in my presentation, I will stop at the decision trees. Thank you.